All right, we're looking at PDFs in this video, probability density functions. Now, these might look unfamiliar because we haven't talked about them quite yet, but we do know an example of a PDF. It's called the normal distribution. So let's go over some properties of the normal distribution. So if we want to calculate a probability, so we've got two values there, A and B, and we would like the probability that we're in between A and B. Well, we've always drawn this as like an area. There it is. So we're looking for that area in between A and B. And how do we find areas? Well, we use integrals. And we can call this function f of x as well. Okay, so if we want a probability, you just integrate between two values. That's cool. And also, the other thing is the total area is 1. So in our case, what that means is that the integral from minus infinity to infinity of the function equals 1. Because there's no sort of limits on the lefts or rights of this function. It just goes on forever. So if we do the integral under the entire thing, we get 1. Now, this is actually one key property of a PDF. So this thing has to be true. The other thing that also has to be true is that f of x is positive. Like always in our range, always. And that is the case. We can look at the normal distribution. It's always above the x-axis there. So these two are what we call sort of like must-haves. We check these two things to make sure something is a PDF. The normal distribution is probably our favorite example of a PDF, but there are many more PDFs that we can have. And they all represent sort of like different things. Okay, so check that f of x is a valid PDF for this one. So it's x squared over 9 between 0 and 3. So what I've done is I've just graphed x squared over 9. I've got the window set from 0 to 3. So is f of x greater than 0? So yes. So it's always above x-axis. And then the second thing we need to check is that the total area equals 1. So what we're after is that the integral from 0 to 3 of f of x, which I'll just put in what that function is, x squared over 9, should give me 1. Now, you can do this by hand. If it's a show that question, I would really encourage you to do it by hand to show you for working. I'm just going to do the integral on the calculator, so you're not sitting here watching me do definite integrals. There we go. The integral is 1 with the calculator. So yes, therefore f of x is a PDF as it satisfies the two conditions. Has to satisfy those two conditions to be a PDF, and that's it. Okay, find the probability that we're between 1 and 2. So this will be the integral from 1 to 2 of our function, which roughly equals, and we can work out that integral. So if we go integral, and I type 1 and then I type 2, it'll give us an integral of 0.259. So we can just directly work out probabilities. Okay, so that's pretty much what you do with PDFs. We'll do more like means and medians and stuff in the next video, but we can calculate probabilities. Before I go on to question 2, I want to give you another example of a PDF. There's one called the uniform distribution. And basically what that looks like is you have two bounds there, and then the function's just at like one set height for all of that. I'd encourage you to think about what this y value would need to be to make sure this is a valid PDF. In other words, to make sure that the total area equals 1. But that's a uniform distribution. Getting continuous examples of that is a little bit weird, but you can imagine like a discrete version would be rolling a die. So you can get 1, 2, 3, 4, 5, or 6, and then each of those has a probability of a 6th. Interestingly, if you add up all those areas, you get 1, which may be in our next topic. Anyway, we've got one more. So this function is AX for between 1 and 4. So it's this graph here, 1 equals AX. We're going in between 1 and 4. Don't mind my scale there. And we would really love it if this total area was 1. That's what we're after to make it a valid PDF. So question 1, is f of x greater than or equal to 0? Yes, if a is greater than or equal to 0, then it is. For property 2, does the area equal 1? So what we want is for 1 to equal the integral of AX between 1 and 4. That's what we need. Okay, now you might be thinking you have to solve this by hand. Sometimes you absolutely do, so make sure you practice doing this one by hand. But I'll show you a cool little trick. A can come out the front of the integral. 1 to 4 of x. And now, this whole thing, we can just evaluate with a calculator. So if we jump back out into run matrix, and we're going to go math, jump across to integral there. So it's the integral of x. And we're going from 1 up to 4. That's 15 over 2. So 1 is a times 15 over 2. And then we can just rearrange that for a. So therefore, a is 1 divided by 15 over 2. If you like fractions, you'll know that's 2 over 15. If you don't like fractions, good news, we've got a calculator. So you can just do 1 divided by 15 over 2. You'll get that number, 2 over 15. Cool. So that's exactly right. And if you want to just check, what you can do is you can go into graph. So f of x is 2 over 15x, and it's a valid PDF. We can just check that this actually works. So if we go 2 over 15, and we put an x there, let's see, we want to set our window from 1 up to 4. There we go. And then in theory, if I do that integral, I should get 1. So you get 1 up to 4. Hey, look, I do. And it's clearly above the x-axis. So yes, it's a valid PDF.